is Science Nightly. I'm your host, Michaela Meyer. Tonight's story focuses on a technology that is used in scientific research, printers, barcode scanners, and hair removal. Lasers. In order to better understand this technology, Science Nightly presents Lasers in Focus. And now, to better understand the history of lasers, let's go to our scientific historian, Kyle Jordan-DeDeaux.
Thanks, Michaela. Lasers have actually been around for an extremely long time. Heck, even Albert Einstein himself in 1917 had thoughts on lasers. But before the laser, there was the maser, or microwave amplification by stimulated emission. It was developed in 1957 by a man named Charles Towns. After the maser, Charles set on how to make it infrared or visible. Throughout the 60s, there was a race to build the first official working laser. And by the end of the decade, many actual lasers were operational and in many research labs and many other institutions around the nation. But shortly after this, Charles Towns received the Nobel Prize for his great work. After this, others started to create and do research themselves on lasers. According to Photonics Media, in the mid-70s, lasers started to become very popular and widely known as what we know them today, such as laser scanners and laser printing. Now here's our laser expert, Tyler Crummett, to explain how a laser actually works.
Thanks, Kyle. Laser stands for light amplification by stimulated emission of radiation. It works by applying electricity to the atoms in a gas or a crystal. Those atoms absorb the energy and their electrons become excited and jump to a higher orbit for something like a millionth of a second. When the electrons fall back to their ground state, they release light particles called photons. Those photons bounce around inside the chamber until escaping through a series of lenses and come out the end. Laser light is special because the light is monochromatic, meaning it's all exactly the same color. The light waves are also coherent, where the waves line up perfectly and don't interfere with each other. The color of this light depends on what substance is being excited. Different diodes produce different colors. Lastly, according to the Lawrence Livermore National Laboratory, lasers can come in any size, from a microchip to the National Ignition Facility, a 10-story tall laser research facility. As you can tell, lasers are pretty useful. To find out just how useful, let's go to our intergalactic correspondent with breaking news, Lake Yoke.
Thanks, Tyler. We have some breaking news for you. Here's the footage. Now on Earth, we have nothing to worry about. The only thing that comes close is the US Navy's laser weapon system, which only takes out small vehicles, not planets. Lasers like the Navy's and the Death Stars are based on chemical reactions. Lasers like common pointers, printers, and those used for hair removal use semiconductors and electricity to generate their light. Experimental lasers base their energy from processes from nuclear reactions to rare chemical compounds. From lasers in our classroom projectors to our Blu-ray players, we can see that they're all around us. Back to you, Michaela.
Thanks, Lake. As you can see, lasers are definitely prevalent in science society today. So it's very good that you know about what exactly lasers do, what their applications are, and how they work. This has been Science Nightly. Good night.